Well, hello everybody. This is a quick video to teach us how to graph in what we call vertex form. So the first thing we're going to do is sort of show you where vertex form, or how it kind of is an advantage. We're going to kind of graph a little bit from standard form. We're going to remember how to find the vertex of a quadratic equation in standard form. So we're going to take this equation up top here, which we've seen equations like this before. It's got a nice perfect square binomial in it, x plus 6 quantity squared, which again essentially means x plus 6 times x plus 6, and then it's subtracting 5 afterwards. So if I want to put this into standard form, right, remember standard form is going to be our ax squared plus bx plus c. What I want to do is do a little bit of distributing. Again, you can do that with the FOIL method or whatever method works for you. So x times x will be x squared. And then I'm going to multiply my x times this outside 6, so 6x. And then we've got our inside, so again another 6x. And then finally we've got our last, right? We did our first, we got our last plus 36 here. And then don't forget that minus 5. Now if I combine some like terms, and again don't forget that this was equal to y will be equal to x squared. We've got 12x here. And then we've got a 31 on the end. Now remember, from standard form, to find the vertex, the next thing we would do is kind of go back and say, well, that means that A equals 1, B equals 12, and C equals 31. And x squared, or sorry, x, I don't know where I got that squared from, x will be equal to negative B over 2 times a, or basically negative 6. And if we plug that back into our equation, negative 6 squared plus 12 times negative 6 plus 31. Again, you can type that in your calculator if you'd like, but basically that's 36 minus 72 is negative 36, plus 31 will be negative 5. We just found out that our vertex then is going to be negative 6, negative 5. Now, all of that work is very, very good work, don't get me wrong, but I'm thinking we could have gotten there a little bit faster. And that's if we take a good look back at our original equation up here in this sort of binomial squared form here with that extra little minus 5 outside. Does that minus 5 seem familiar? Didn't we just find out that the y value of our vertex is going to be negative 5? And hey, wait a minute. Thinking back to intercept form, or sort of those factor ideas, wouldn't negative 6 be a great number to turn this binomial in here to 0? Or if I plugged negative 6 and made this 0, right? Negative 6 plus 6 being 0. 0 squared would still be 0. And 0 minus 5 gives me that easy negative 5. All of this work, like we said, is very good work, but very unnecessary if we know vertex form. So let's take a good look at what we call vertex form. Vertex form says y equals a times, again, that binomial square, x minus h squared plus k, where h is a horizontal shift. Right? We're subtracting, adding and subtracting was always a shift. Since it's inside the parentheses, it's being squared inside the parentheses before we square it. Again, that's a horizontal shift. Now, we've talked about vertical shifts before. Again, vertical shifts happen last. They happen outside. So notice that's plus k out here. So k is our vertical shift. And finally, a, that coefficient or the constant in front, that scalar multiple, is a vertical stretch if it's greater than 1. It can be a vertical shrink if it's a fraction between 0 and 1. And if it were negative, it would also be a vertical reflection. This has taken us back to all those transformations we've talked about before. So as we look at our equation here, what's the difference between y equals x plus 6 the quantity squared minus 5 and just regular old x squared? Well, first of all, inside we've got a plus 6, so we would call that a horizontal shift. Now here's where it gets a little bit tricky. Remember on the last screen, it takes a negative 6 to turn this to 0, to turn that factor into 0. Which means technically, instead of 0, 0, right, where our normal parabola would be, right, start at 0, 0, go right one, up one, go right another one, up 3 more, right, to get to here. We draw that parabola for x squared, right? We do the same thing the other direction and draw the other half of that parabola. Well, we need to plug in, again, as we just said, negative 6 to get to our vertex. As we found on the previous screen, negative 6, negative 5 is going to be that vertex. So we're going to horizontally shift left 6 units. If it's x plus 6, I know our minds tell us, oh, plus 6, that's got to go to the right. But notice, again, it's what number am I plugging in? It's not the fact that that's plus 6. It's what number do I plug in to make that into 0, to make that quantity turn to 0. And to do that, I've got to go left 1, 2, 3, 4, 5, 6. I've got to get my axis of symmetry over here. Right? At x equals negative 6. Then, notice we're also going to say minus 5. We're going to shift down 5, k being negative 5. So vertically shift down 5. So we're going to take this and go 1, 2, 3, 4, 5. We're going to put our vertex way down here so that now if we found more points, and again we can take these points and we can shift them left 6 and down 5. We can have a little symmetry going on. Again, same thing, I can go left 6 over to negative 4 and down 5 takes me to negative 1. And now I could draw that parabola again. Right? We're running out of room on the screen there. I can draw that parabola over there on the left side. Vertex form gives me a very fast way of number one, identifying the vertex. Vertex of h, k. And note that again, x minus h is in the formula, which means I need to sort of change that sign. Whatever number I have, like plus 6, is going to become a negative 6. H is the number in there. And k gives me my y-coordinate. Notice we had a positive 1 out in front, so we already know, again, that's going to open upwards. And if you remember your old 1357, vertex form is also very helpful with our 1357 shortcut. Because if we can identify the vertex very quickly and simply, I can get all the rest of my points quickly from my formula, from my 1357 formula. And then finally, repeat the process to the right or left, depending which one you started with, and you're quickly done. So let's try this one out up here. We've got y equals x minus 3. So now let's remember, again, what can I plug in that would turn this quantity into 0? Remember, I want 0 minus 4. I want that negative 4 to show up as my y-coordinate. So if I plugged in negative 3, that's going to be negative 3 minus 3 is negative 6. Well, negative 6 squared is not going to be 0. I want to plug in positive 3. X minus 3 tells me to shift right 3. And if I can go right 3 and down 4, 1, 2, 3, 4, I can get that 3, negative 4 very quick and simple. And now we can use our 1357 method. From the vertex, from that point that's on my axis of symmetry, right? Get that labeled in there. X equaled positive 3. Right? So we'll write it off to the side here. Axis of symmetry. Right? X equaled 3. Well, we can take that point, and since I know that this is a positive 1 in front, I can count right 1 up 1, right 1 up 3, right 1 up 5. I could also go, sorry about the stray mark there, get rid of that real quick for us. Again, I can go left 1 up 1, left 1 up 3, or I can take these points and sort of reflect them over. And if you don't trust whether or not that's working correctly, check one of those points. You know, 0, 5 right now seems like a great point to double check. 0 minus 3 would have been negative 3, squared is 9, and 9 minus 4 is 5. I know that when I plugged in 0 for x, I got back a positive 5 for y, which just falls directly on the line that I thought. I apologize for the squiggly lines here. I'm working on those parabolas, smooth as we can be. I know that those points fall on that line, and those lines continue to go upwards, just like that. Take a second. I'm going to reveal this equation down here. Think about this equation. See if you can identify the vertex, and then see if you can plot that equation at home. I'm going to pause the video now and fill in the information. Good luck. Alright, here we are back again. Again, I took a good look at my equation. What would make my quantity equal 0? Well, if x was negative 2, negative 2 plus 2 would have been 0. 0 squared is 0, times negative a fourth is 0, plus 1 is 1. Negative 2, 1. Looks like a really good vertex. So I drew my axis of symmetry. And then I actually took advantage of the 1, 3, 5, 7, remembering that, again, that negative 1/4 means don't go down 1, 2, or 1, 3, 5. I'm going to go negatively, though. I want to go downwards, right? We're going to open down. Our maximum would have been 1. But I'm going to go down 1/4, 3/4, 5/4, 7/4. I can still use those odd numbers, but again, I need to count in fourths on my graph. Again, hopefully that helps you out, graphing vertex form. The big thing to remember about our parabolas, now we know 3 different good forms of a graph. We know standard form, where we can start with that x equals negative b over 2a, get ourselves an axis of symmetry, use that to help us find the vertex, and again, use that vertex to decide on more points. We can do intercept form if we're in factored form down here. Right? We can do intercept form, where p and q would be our x-intercepts. Halfway in between, we could find that axis of symmetry, right? Use that average idea, p plus q over 2. And once we have that axis of symmetry, find the vertex, a couple more points, and again, we can get that nice parabola going on. Finally, today we just learned in vertex form, probably the fastest way to graph, though kind of a pretty technical equation. Vertex form, y equals a times x minus h quantity squared plus k. If I can identify h and k, then h is my axis of symmetry, h comma k will be my vertex. And again, if I know my vertex, I just need a few more points, again, around that vertex, and we can graph our equation. All helpful parts of a parabola, depending upon what kind of form are you starting from. You have to recognize, do we have that binomial square? Do we have 3 separate simplified terms, right? X squared, x, and the constant? Or do we have 2 factors multiplied? Again, all of which have a out in front of them, all of which we can use a lot of the same ideas to help ourselves with. If you have any questions, talk to your teacher. And again, good luck and happy parabolas.